So today's topic is classification of liquid solution. So for a liquid solution, for the component 1, Raoult's law is P1 equal to P1 not X1. For the liquid component 2, Raoult's law is P2 equal to P2 not X2. So a liquid solution, Raoult's law obeys or not. On the basis of it, liquid solutions are classified into two types. First one is ideal solution, another one is non-ideal solution. So Raoult's law obey or not, liquid solutions are classified into two types, ideal solution and non-ideal solution. Now I am going to differentiate between ideal and non-ideal solution. So basic difference between a ideal and non-ideal solution is ideal solutions obey Raoult's law at any concentration of the solution. At any concentration of the solution. That is, for the component 1, P1 equal to P1 not X1. Similarly, for the component 2, P2 equal to P2 not X2. That means किसी भी आइडियल सॉल्यूशन राउल्स लॉ ओबे करता है किसी भी कंसेंट्रेशन में, बट नॉन आइडियल सॉल्यूशंस डू नॉट ओबे राउल्स लॉ. That means for a non-ideal solution, P1 not equal to P1 not X1. Similarly, P2 not equal to P2 not X2. P1 not equal to this means P1 may be greater than P1 not X1. Similarly, P1 may be less than P1 not X1. Similarly, P2 may be greater than P2 not X2 for a non-ideal solution. Similarly, P2 may be smaller than P2 not X2. So this is the basic difference between the ideal and non-ideal solution. This is the basic difference. Then suppose one question, what is ideal solution? Then you have to write this definition. Ideal solutions obey Raoult's law at any concentration of the solution. Second difference between an ideal and non-ideal solution is second difference is related to heat or enthalpy. Enthalpy, when enthalpy changes positive, process is endothermic. When enthalpy changes is negative, process is exothermic. So enthalpy changes, second difference between ideal and non-ideal solution, enthalpy changes during the mixing of two components is equal to 0. That means delta H mixing is equal to 0. Delta matlab change H enthalpy during the mixing is equal to 0. That means जब एक आइडियल सॉल्यूशन प्रिपेयर करने के लिए दो लिक्विड कंपोनेंट को मिक्स किया जाता है, ड्यूरिंग द मिक्सिंग नाइदर हीट इज रिलीज्ड नॉर एब्जॉर्ब. लेकिन जब एक नॉन आइडियल सॉल्यूशन प्रिपेयर किया जाता है, ड्यूरिंग द मिक्सिंग ऑफ टू कंपोनेंट्स एंथैल्पी चेंजेस इज नॉट इक्वल टू 0. delta H mixing not equal to 0. That means during the mixing of two components, either heat is released or absorbed. So third difference between an ideal and non-ideal solution, the volume changes during the mixing of two components is equal to 0. That is, volume changes, delta change in volume, delta change V volume during the mixing is equal to 0. That means जब एक आइडियल सॉल्यूशन बनाने के लिए दो लिक्विड डेफिनिट वॉल्यूम में मिक्स किया जाता है, दोनों लिक्विड का डेफिनिट वॉल्यूम मिक्स किया जाता है, देन वॉल्यूम नाइदर इंक्रीज नॉर डिक्रीज. जैसे कि 25 मिलीलीटर्स ऑफ ए लिक्विड 1 is mixed with another 25 milliliter of another liquid 2, then how many total volume of the solution? 50 milliliter solution we have. 25 मिलीलीटर लिक्विड 1, 25 मिलीलीटर लिक्विड 2 का साथ मिक्स कर देने से टोटल वॉल्यूम कितना होगा 50 मिलीलीटर. लेकिन in case of non-ideal solution, the volume changes during the mixing of two components is not equal to 0. That is, volume changes during the mixing of two components not equal to 0. So volume changes may be greater than 0, it may be less than 0. Suppose 25 milliliter of a liquid 1 is mixing with another 25 milliliter of another liquid 2. So total volume is not equal to 50 milliliter. So 25 milliliter of liquid 1 when mixing with 25 milliliter of another liquid, total volume of the solution is not equal to 50 milliliter. The total volume of the solution either greater or smaller than 50 milliliter. So fourth one difference between ideal and non-ideal solution, the solvent solute interactions. Let us consider A solvent, B solute. Solvent solute interactions is equal to solvent solvent AA and solute solute interactions. That is, AB interaction, solvent solute interaction equal to solvent solvent and solute solute interaction. प्योर सॉल्वेंट में क्या होता है, सॉल्वेंट सॉल्वेंट इंटरेक्शन होगा. प्योर सॉल्यूट में सॉल्यूट सॉल्यूट इंटरेक्शन होगा. जब सॉल्वेंट सॉल्यूट का साथ मिक्स कर दिया जाएगा, न्यू इंटरेक्शन डेवलप होगा, दैट इज ए बी इंटरेक्शन. सो पर्टिकुलर एक सॉल्यूशन में कौन सा इंटरेक्शन होता है, सॉल्वेंट सॉल्यूट इंटरेक्शन. लेकिन जब एक आइडियल सॉल्यूशन प्रिपेयर किया जाता है by the mixing of two liquid components, then in the solution solvent solute interaction is equal to solvent solvent and solute solute interaction. But in non-ideal solution, solvent solute interactions in the solution is not equal to solvent solvent and solute solute interaction. That is, in a non-ideal solution, solvent solute interactions in the solution may be greater than solvent solvent and solute solute interaction, or AB interaction may be smaller than solvent solvent and solute solute interactions. So these are the differences between the ideal and non-ideal solutions. Now an example of an ideal solution is benzene dissolves in benzene found in liquid state in toluene. These are two organic compounds, they are found in liquid state. When benzene dissolves in toluene, we have an ideal solution because in this solution solvent solute interaction is equal to solvent solvent and solute solute interaction. Similarly, bromoethane, it is an organic compound found in liquid state in chloroethane, it is also an organic compound. Bromoethane in chloroethane, also an example of ideal solution because in this solution also solvent solute interaction is equal to solvent solvent and solute solute interaction. But in case example of non-ideal solution, ethanol in acetone is an example of non-ideal solution. In this type of solution, solvent solute interaction is not equal to the solvent solvent and solute solute interaction. Similarly, chloroform in acetone, also another example of non-ideal solution. So these are two examples of non-ideal solutions. So in a non-ideal solution, solvent solute interaction is not equal to solvent solvent and solute solute interaction. So these are the differences between the ideal and non-ideal solution. So non-ideal solutions again classified into two types. non-ideal solution having positive deviation from Raoult's law, and a non-ideal solution having negative deviation from Raoult's law. So non-ideal solution again classified into two types: non-ideal solution having positive deviation from Raoult's law, and non-ideal solution having negative deviation from Raoult's law. So difference between these two type of solution: in case of positive deviation, P1 is greater than P1 not x1 for the component 1, and P2 greater than P2 not x2. But in case of negative deviation, P1 smaller than P1 not x1, and P2 is smaller than P2 not x2. And second difference, enthalpy changes during the mixing of two components is here greater than 0. Greater than 0 means delta H mixing enthalpy changes during the mixing is equal to positive. That means process is here endothermic. That means during the process, during the mixing of two components, heat is absorbed. But in negative deviation, enthalpy changes during the mixing of two components less than 0. Less than 0 means what? Negative delta H enthalpy change is negative. Negative होने से process होता है exothermic. Process is exothermic. That means heat is released. So in positive deviation, enthalpy changes is greater than 0. That means positive. Or in negative deviation, enthalpy changes is less than 0. That is negative. That means process is exothermic. Third difference, volume changes during the mixing of two components is greater than 0. That means volume increases during the mixing of two components. And in negative deviation, volume changes during the mixing of two components less than 0. That means volume decreases during the mixing of two components. And last one difference is here solvent-solute interactions in the solution. Solvent-solute interactions in the solution is smaller than the solvent-solvent and solute-solute interactions. But in in negative deviation, solvent-solute interaction is greater than the solvent-solvent and solute-solute interactions. So these are the differences between the non-ideal solution having positive and negative deviation from the Raoult's law. Example of a solution having positive deviation from Raoult's law is ethanol in acetone is an example of non-ideal solution having positive deviation from Raoult's law. Why ethanol in acetone is showing positive deviation? Because in this solution AB interaction, that means solvent-solute interaction, is smaller than the solvent-solvent and solute-solute interactions. And an example of a solution having negative deviation from Raoult's law is chloroform, which molecular formula CHCl3 in acetone molecular formula is CH3COCH3. So this is an example of liquid solution. It is showing negative deviation from Raoult's law. So why this solution is showing negative deviation? Because in this solution solvent-solute interaction is greater than the solvent-solvent and solute-solute interactions. So chloroform in acetone, it is a non-ideal solution. It shows negative deviation from Raoult's law. Why it is showing negative deviation from Raoult's law? Because in this solution AB interaction is greater than AA and BB interaction. When chloroform dissolves in acetone, hydrogen bonding is formed. So hydrogen bonding is the strongest intermolecular forces of attraction. So when acetone acetone sorry acetone 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 dissolves in chloroform dissolves in acetone, then hydrogen bonding is formed. So this is the hydrogen bonding here. This is the hydrogen bonding between the molecule of acetone. This is acetone molecule, this is acetone molecule, this is acetone molecule, and this is the chloroform molecule. So when acetone dissolves in chloroform, what type of interaction is formed? Hydrogen bonding. Therefore chloroform in acetone solution, AB interaction is greater than the AA and BB interactions. So